Okay, now we're going to talk about averages, since we actually talked about Moodle before. If the green block, look, I have blocks, weighs 1.5, it pretty much does. Then, if I have the total of the blocks on the screen, 2 greens, 1 red, and 6 blues, what is the typical weight of a block? And I'm very purposefully picking the word typical because it's a little vague in English, what we mean by typical. So talk about that with somebody next to you, or go to somebody if you're sitting all by yourself. I'll pause the recording and think about what typical means. What's the typical weight of a block in this group? How would you explain it to me? And like that. If you're at home, also figure this out while we're paused. Okay, I'm resuming the recording. The camera is pointed down just as a reminder that the blue blocks, do this to the camera, are exactly as big as 2 green blocks. And the red blocks are the same size as 3 green blocks. So if you missed that from last week, then there you go. Okay, but looking at people now.
But it says a block.
Yes, you want the typical weight of a block in the group, not what's the total weight of the group. So what do people think? This front group here, did you have an answer you like?
3 grams.
3 grams. And why did you say 3 grams?
Because of that, we were going off of that 1.5 grams. Some typical weight would be because there was more purple. And it weighed twice the amount of green triangle.
Okay, so the most common one is the blue, and it weighs 3. So a typical weight is 3. Okay, that is a good way to say it.
Exactly what we said.
That's exactly what you said in the back. Okay, and then the other group in the back?
25.
That sounds like a total. You added them all up. Okay, so they just converted it all into greens and did that many times 1.5 or something like that. Okay, so there's 3 ways that people answer this. One of them is the way that 2 groups already said things. Which block happens the most often? That's the thing we'll call typical. There's more blue diamonds than anything else in the group. So blue diamonds are typical, and whatever they weigh is the typical weight. Make sense? There's also a slightly different way to look at it that I'm going to call most representative. And that one doesn't say which block is the most of, but rather it says the blocks that there just aren't lots of are disqualified. It kind of winds up the same thing often. So it will say there's just not very many green or reds, so we disqualify them. What's left, in this case, the blue. So the blue is typical and blues weigh 3. Make sense? Okay, the last way to think about things is the math term you probably have been taught in school before as average, where you add them up and divide by how many. So the group that added them up, what was the total again?
25.5 is added.
Okay, well, we'll do that. So 25.5, adding them all up. How many blocks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So do it divided by 9. And what do you get? I'll use I'm rounding squiggly equals. 19 is too big.
2.8.
2.8. So again, if you rounded it, you could say it's also about 3. The answers all kind of match.
Okay.
So those are all perfectly valid ways to define typical in English. You can say it's the thing that happens the most is typical. We could say things that don't happen enough are disqualified from being called typical. Or we can say, let's add them up and divide by how many. Okay, I'm going to move to the next thing. I'm going to get rid of this. Okay. Uh-oh, now somebody added 2 giant yellow blocks. Those are equal to 6 green triangles. If you remember, you can cut them and make 6 green triangles out of each yellow. 1, 2, 3, 4, 5, 6. Could we do the same thing? If you thought that the definition of typical was the thing that happens the most, your answer doesn't change at all. You're still going to say there's mostly blue. Blue weighs 3, so 3 is typical. If you're going to say, let's toss out anything that there's only a little bit of, then you would toss out the greens and the red and the yellows because there's only 1 or 2 of those. What's left would be blues, and blues weighs 3. So you again would, with that method, still say 3. If you're doing to add them up and divide by how many, then your number will change. You won't get 2.8. You would get something else. You're welcome to do that on your own time. So this is another feature that based on which definition of typical you use, then your answers might change a little for the question. And that's okay. It can still be correct because we're not saying any official math words. We're just saying the English word typical. So beware of this when people are not using math language carefully, that you can have different answers that are all okay. And if you change the circumstances, some people's answers might change and other people's might not, right? So we want to avoid this. We want to have our math language be more careful so that there's one right answer and we can all agree on how things are. So the first definition is mean, M-E-A-N, and this doesn't mean like people hitting each other. This is just one of these weird words that math decides to use and have its own definition. So the mean is the kind of average that we just did, that most people are taught in school. Add them up, divide by how many. If I want to find the mean weight of these blocks, the blocks, by the way, they're all the same size, but they weigh as much as the number on the scale. So these 2 blocks weighed 2 grams or pounds or whatever you want to imagine. This block weighs 6 and this block weighs 10. So I will write those on that they look the same, but really these weigh 2. This weighs 6 and this weighs 10. So when I add them all up, what's the total? 2 and 2 is 4. 4 and 6 gets us to 10. Another 10 is 20. So total is 20. There are 4 blocks. So after that, we're going to do a divide by 4. And what's 20 divided by 4? And you can see that it looks like if you put these on the balance scale, 5 is about where it would balance. Our brains are actually very good at this. If you make a histogram out of things, the balance point that you visually see is usually very close to what the mean would be if you actually did the adding up and divide by how many. Often the data is just kind of more messy, more than 4 things, weirder numbers. So we can't picture it on a balance scale as well. Let's do one like that. Don't change it yet? Okay. Pause real quick. So there's a preschool classroom and the students' weights are these numbers up above: 34, 36 3 times, 37 twice, 38, 39 twice, 40 twice, and 41. So what is the average weight of them? Here is another histogram. Just eyeballing, where does it look like it will balance? So somewhere like that, it will balance. That looks, it's too heavy on the left to me once I draw my little balance thing.
I can visualize that in your head.
So it'd be like 37.
Between 36 and 37.
between 30, if I draw it there, that makes it look, then it's gonna tip down on this side.
Side of 37.
Others, so like here, something like that. So 37.5 might be our guess. Let's actually do this. So let's add everything up. I'm going to pause for a moment in the video. Okay, resuming the recording, I opened up my online calculator thanks to the website named Desmos, and I added these things up. So we had 134, 3 36s, 2 37s, 138, 2 39s, 2 40s, and a 41. If I did this right, it's 453. So that was the total. So I will write that down. We actually have a unit of weight, so I'll be good and write that down. Okay, how many students are there? 12, so divide by how many? So the 453. Then we're going to take the answer divided by 12. And we get 37.75. Remember our rules for rounding from earlier. Do we really know this to the 10th, 100th of a pound? No, we didn't weigh the students that accurately to start with. We just knew them rounded to the nearest pound. So keep the same number of digits of accuracy. So just round it to 38 without any decimal points, or add one more, 37.8. Which one do you want to do? They are both quite legitimate ways to write the answer. 38, okay. And you can see that our eyeballing was pretty good, right? It's right about there. That would balance things. So that is called the mean. It is the official math jargon for the kind of average you probably already knew, where you add them up and divide by how many. There is a problem, though, with the mean, that some big number at the edge is going to throw things off. In this case, the $530,000 house isn't really very typical of the other houses in this neighborhood. Somebody did a lot of remodeling compared to all of the neighbors. And you see this in other demographic examples. If I say, what is the average income of people in this neighborhood in Eugene, then if there's one person that is, trust fund baby, has lots of stocks, they're going to throw things off. If I say, what is the average number of kids for people in this room, if somebody has 8 kids, then they're going to throw off the average with the add them up and divide by how many. So there are lots of examples of things in real life where you don't just want to add them up and divide by how many, because the numbers that are either unusually big or unusually small will seem more significant than they are. A big example of this is unemployment. When you're wondering about unemployment data, do you count all of the people that are, quote, eligible for work, the right age, the right health, and so on, and include them in the percentage of people with jobs? Or do you only include the people that are actually looking for work, right? If there's someone that's young and healthy and could be working, but they are taking some time off to travel or whatever, then are they unemployed or not? You get very different numbers for the unemployment based on if you only are picking the people that are trying to work, or if you pick everybody and there's a lot of zeros in there the other way. So I'm going to stop the recording and then we'll talk about how to fix that problem with the mean.